Alright, here's another tough question. People love to hate on these composite functions. F of g of x. This is the same thing as f of g of x, which is f of, what's g of x? F of x squared. Well, f of x squared is the square root of x squared minus 2. So I take whatever's in here and put it in for my variable in the f function. So that's our answer. What are we allowed to put in for x, for our domain? Well, we can't put anything for x that would make underneath there a negative. So let's see. How would I do that? I think I would probably maybe plot it. So y is radical x squared minus 2. So we definitely have a strange thing going on in the center. Let's take a look at our table. Oh, so we have errors going on anywhere. Well, where would x squared minus 2, where is that negative? Where is that less than 0? Again, we can't take the square root of a negative. Well, that's where x squared is less than 2. Oh, that's where x is less than less than radical 2. Or, this is like, or it's where x is bigger than negative. It's where it's that range. If you look at our, that's the value that's giving us errors. Notice. So, our domain is that x can go from negative infinity to negative radical 2. Is it allowed to be negative radical 2? Yes, it is. It is allowed to be that because that gives me 0. And then it's also, so I got to use union from, excuse me, it is allowed to be positive radical 2 all the way to infinity. That's how you write the domain. Okay? Alright, so what is g of f of x? Let me erase this real quick. Well, what's f of x? Well, that's g of radical x minus 2. So now, I'm going to take this, I'm going to take whatever I have for my x, and I put it in to the g function. So I'm going to square it. And what do you get for that? You get x minus 2. So g of x is x minus 2. What's the domain for that? I think it's everything. So negative infinity to positive infinity. And are they equal? No, they are not. I hope I did that right. I do believe I did. Hope that helps. Boom!